What I'm going to do is, again, as Troy said, put about a 20-mile-an-hour positive pressure on the exterior of this house. I'm going to make this house suck air, depressurizing the interior of this house. Then I'm going to create a 12-inch hole in the outside of the exterior wall here, basically open a window. What we do is we depressurize to 50 pascals of pressure on the exterior of the house. While that number is there on my manometer, I'm getting a reading of what the envelope leakage is at that point in time. So somewhere between 49 and 51, I'll mark my reading. We'll get that number, and then I'm going to make a 12-inch hole for you on the side of the house here via a window and show you how much infiltration occurs just by 12 inches. Now, typically you won't find a 12-inch hole in one spot through your envelope of your house. You're going to find it in little tiny holes throughout the exterior of an envelope of the house. This is very crucial because all these little holes do add up to a big hole. So we've been doing this, and we've been getting around 1900 CFM of leakage, and just by making this 12-inch hole, we increase that leakage almost 700-800 CFM more leakage by doing this. So what I'll do is I'll go ahead, I've got my blower door set up, we're going to depressurize it, and we'll make a hole here. Now you'll see this starting to come in. This is the amount of pressure I'm exerting on the house now at 25 pascals.
Well, the house is not sealed at 25 pascals. That door is not even going to move because it's sucking from every leak in the house. And like my house, the first one we did, I couldn't get this test to work.
We're at
it's so bad.
About 1874 at 50 pascals of pressure. Now what I'll do when I open this window here to make this hole, my pressure is going to drop, so I'll have to repressurize to 50 pascals. And you'll see the curtain. I'll call that about 12 inches there, roughly, in a square. Now I drop from 50 back down to 25.
There's nowhere else this house is getting able to suck, so it's all coming from that window.
Went from 18.
You'll feel the temperature drop, and you'll feel it get uncomfortable in here really quickly.
To 2800 CFM. So we basically increased 1,000 CFM of leakage just by having a 12-inch hole. And again, keep in mind, these are all holes this big that somebody missed and didn't see them because they said, hey, it's not going to matter. It matters 1,000 CFM of air coming into your house on a windy day. So it does make a difference. Now watch, I'll turn this off and that curtain will stop. Everything goes flat. Now this again ensures that our company, Key Insulation, has in fact sealed everything up. I confirm that by performing this test. Based on the square footage of this plan, we have a goal for 6% leakage of the volume of the envelope of the house, which I use more or less about the square footage as a cheat sheet for myself because we have so many new plans that come out. I don't always get updated before I'm testing them. But again, because of my 10 years of experience, I can pretty much say, okay, we have achieved our tightness that we need. Weather stripping, each door that's not weather stripped is about 150 CFM of air that comes in. One of the good things about this test is if you're not using a foam or haven't used a foam, if you have any types of ductwork that's separated, that's open to your attic, which would typically not be foamed, you have your AC or your roof vents up there, I would be able to detect a leakage in the duct system somewhere along the lines because, again, I would not be able to depressurize this house to 50 pascals because I'm sucking all that air from the attic or AC closet, wherever the case may be. So it kind of is a double check for me so that we don't perform our duct leakage test a second time. We do that typically at the framing stage of construction so that if there is a problem with the excessive leakage, again, we look for 6% or less, we're able to have the AC contractors come out, seal up, so they don't have to cut holes in sheetrock and delay, all the other trades from getting in here.
So, part of that, where he's talking about that, like we'd actually be pulling, like if where Bob's standing there, right, there's a little door, the door catch there. When he turns this on, if you would have felt there, you can actually feel air come out of it. And what it's doing, that's actually sucking all the way down from the attic. So that's why I'm saying that the key is to have a positive pressure. We want like 3 pascals of positive pressure on the house, so when you have those leaks, you're not sucking the hot air in, you're pushing the cold, you're forcing it out. So that's why it's so important.
Pascal's
Pascal, it's just a unit of measurement, right?
Right, it's less than a CFM. They equate it
What's
to
a CFM?
cubic foot of air per minute. CFM,
Okay.
cubic feet per minute. But basically, 1 pascal of air pressure would be if you took a yellow stickum note, you took it off, and you dropped it. The amount of air pressure that is exerted is 1 CFM. So I mean, they call it like a gnat fart, basically. I mean, it's
one Pascal.
1 pascal.
That's what 1 Pascal.
1 pascal. I'm sorry, I may have said CFM, but 1 pascal, right? I mean, it is absolutely nothing.
Okay.
Like I say, I don't know if you can feel that through that.
That's why I said you wouldn't be able to feel 3 gnat farts in our house. Yeah, 3 pascals of positive pressure. So that's going to get me in trouble, Ralph. Thank you.
It's my last day. I had to throw that
That's
out
right.
there.
But I mean, for example, did you have